Hello. ఎలా ఉన్నారు? I hope all of you are doing very well. This is Vps Rajawat. Welcome back to my channel, The Vps Physics. In today's video, we are going to discuss about reflection at curved surface. Before starting this video, let me tell you something. No need to take any screenshot. I will provide this PDF, okay, in the Telegram channel, which I've shared the link in the description. If you don't have Telegram, DM me on my Insta. I will share there. Okay, let's start. So, these are the important topics from this particular chapter. What I observed after looking at PYQs, from these topics they are asking question frequently, from ray diagram, from lab activity, and when from magnified. अब देखो ये तो point number 3 है ना बेटा, magnification values. So what they will do, they will give one table. Okay, in that table they will ask 3 to 4 questions for 4 marks. Okay, but the last one is application and the consequences type of question. How write the application of spherical mirror in day-to-day life, or how they can ask what will happen if you use this mirror in place of this mirror, and focal length how it will depend on the medium, does it not depend on the medium, that type of question they will ask in this particular method. Okay beta, let's start. First thing, basic of spherical mirror. Now see, we have to make mirror. For mirror, what is necessary thing? We have to polish one surface, so other side will behave like reflecting surface, will get reflection, then phenomenon of mirror will happen. Okay, here beta we have to make spherical mirror, which means the shape of the mirror should be spherical. So what we are doing, we are taking hollow sphere, then we are polishing. Now beta we can polish inside also, outside also. If we polish outside, then beta mirror become concave mirror. If we polish inside, then beta mirror become convex mirror. As you can see in this diagram, but here the blue part we are polishing outside. Okay, so this particular mirror is concave mirror. Okay, if you see what other diagram, here we have polished inside, so this mirror is convex mirror. Okay, if I talk about better terminology that we have to use in this mirrors, if you see the blue part is there, and better we have the center of this blue part, that is known as pole. This beta center of this reflecting surface is known as pole, and center of this hollow sphere beta C, this is known as center of curvature. Distance between C and P is known as radius of curvature, that we will write R, and beta C and P, one point is there, that is focus point. What is focus point? Beta when rays come parallel to principal axis, so they will meet a point, that point is focus. Okay, distance between focus and pole is known as focal length. Okay, what is principal axis? What is the axis which will pass through the center of curvature and pole. Okay, but one more thing is there, that is focal plane. But we use this focal plane to making ray diagram when ray of light coming at an angle on the reflecting surface. Okay, so what is focal plane? But it is a plane that is perpendicular to principal axis, and that will pass through the focus. Okay, here, so but here what I have observed, ki student feel sign convention problem. Why sign convention? Because beta we have two formulas in this mirror case. One is beta mirror formula, 1 upon f equals to 1 by v plus 1 by u, where v is the image distance measured from the pole, u is the object distance measured from the pole, and beta f is the focal length. Okay, so how to do the sign convention? Beta focus here. I will tell you one simple trick. Okay, very simple. So whatever you see in front of the reflecting surface, that will be negative. Whatever you see in front of the reflecting surface, that you have to take negative. So here beta this part going to be negative, this part going to be negative, and behind the beta mirror it going to be positive, or what you can say, side of polished surface is going to be positive. Beta side of polished surface going to be positive, you can see in this particular diagram. Okay, one more formula we have, that is beta magnification formula, that is minus v y u. Okay, this minus beta coming through derivation. Okay, after writing all the like v u with sign convention, we have to keep this minus, then we will see m coming positive, negative. What is this magnification? But a magnification tells us about the image, what is the size of the image compared to object. Okay, it is big, it is small, it is same size. So the value of m, I am taking beta magnitude wise, if value of m beta equals to 1, which means image is same size as object. If beta m is greater than 1, which means beta image is enlarged. What is happening to pen? Beta image is enlarged. If this m is less than 1, which means beta image is diminished. Beta diminished meaning कि size of the image is small compared to object. Enlarged meaning size of the image is more than the object. But this m can be positive also and m can be negative. Whenever m positive, this tells beta कि image is erect in nature. Image is erect in nature, and m negative beta tells कि image is inverted in nature. Meaning of erect, suppose beta this is principal axis, okay, and object is here. So what is meaning of erect? If object is here above the principal axis, so image also going to form beta same side. बोले तो sir above the principal axis only. Suppose m getting positive and object beta down the principal axis, so image also going to form beta down the principal or below the principal axis. M negative means inverted image. What is that meaning? This is principal axis, suppose beta this is the object, so now image inverted, which means if object above the principal axis, so image going to beta form below the principal axis. That is meaning of inverted and erect. But let's move further. Okay, now beta we have one more property of this concave mirror and convex mirror. But a concave mirror converges the ray of light, that's why we'll tell कि concave mirror is converging mirror, and convex mirrors diverge the ray of light, that's why beta we tell कि convex mirror is also known as diverging mirror. You can see this diagram, but here ray of light coming from infinity, they are beta converging at focus. Here beta they are converging at focus. If you see diagram for convex, ray of light going diverge beta, but if we extend the reflecting part or beta the reflected rays, we'll see कि they are coming from the focus. Okay, so diverge means convex and converge means concave. Now beta we have to study ray diagram. Why ray diagram? To make beta image formation we have to study ray diagram. We have beta 6 cases for concave and 2 cases for convex. For making an image we need beta intersection of two rays, which means for making any image we have to apply beta 2 rules. Okay, so beta rule number first, here you can see कि beta whenever ray of light coming parallel to the principal axis, it going to pass through the focus. And rule number 2, whenever ray of light coming through the focus, but it will become parallel to the principal axis. Rule number 1, sir, parallel to principal axis going to pass through the focus. Rule number 2, it is coming through the focus, after reflection it become beta parallel to the principal axis. Beta rule number 3, whenever ray of light come on beta center of curvature, it will retrace its path or it will follow its path back. Okay, what is the reason? Because beta here incidence angle become 0, I 0 to R also 0, laws of reflection. Beta rule number 4, whenever ray light coming on the pole, okay, it will beta going back with same direction, not same direction. Beta rule number 4, whenever ray light incident on the pole, it will get reflect back with the same angle. One more thing, whenever writing beta image, use any 3 rules between these, like 4 are there, but you can use these 3, and in these 3 especially 2. Why not this one? Because beta here we have to make this angle same. Sometimes we do mistake, okay, to making the angle same. It's not to use this one, it's better to use any 2 in first third. Okay, now beta we have convex mirror. So whatever is happening in concave, here beta it will like it is appearing. Okay, how we can say? But rule number first, here what was the rule number first? कि whenever ray light passes or whenever ray light beta coming parallel to the principal axis, it passes through the focus. Here what will happen? Whenever ray light beta coming parallel to the principal axis, it's appear like it is passing through the focus. If you keep one finger on the beta this incoming ray, you will see कि this dotted line coming through the focus. Rule number 2. Rule number 2 beta, in concave case, whenever ray light coming on the focus, it become parallel to the principal axis. Here in convex, it will appear it is coming on the focus, but after reflection it become parallel to the principal axis. But rule number 3 also same. If it is coming on center of curvature, it appear it is again going back from the center of curvature. And rule number 4, coming on the pole, it will reflect back with the same angle. Okay, so these 4 rules are there. You have to use them to make an image. Now we will see ray diagram by concave mirror and convex mirror. बेटा देखो होता क्या है, what happens, let me draw here, this is concave mirror. Okay, how many position we have? Pole, focus, center of curvature, okay, and somewhere infinity. So where we can keep the object, sir, at infinity, then beyond infinity beta here, then sir on center of curvature, between center of curvature and focus, on focus, between focus and pole. So beta there are 6 cases in case of concave mirror, so we can get an image. We'll discuss one by one. But the first one, object at infinity. Object at infinity. But object at infinity or image at infinity meaning is कि rays are parallel to the principal axis. Okay. So here beta object at infinity, which means incoming ray or beta incident ray are parallel to the principal axis. Rule number 1. Whenever ray light beta parallel to the principal axis, they are going to pass through the focus. See, beta coming parallel to the principal axis, passing through the focus. Here also coming parallel to the principal axis, passing through the focus. So now what we can comment about image? So real intersection is happening, which means real image. But a point size image, and always remember, but a real image always are inverted image. Okay. And what about position? Position beta at focus. Okay. If this question beta comes 6 marks, then how you have to write? First you have to draw the diagram. Okay. Then you have to mention each and everything. What is pole? What is mirror? What is focus? What is center of curvature? Okay. Then you have to write rules. Okay, how many rules you are using? Then you have to write characteristic of image. First point should be position of image, then go on. Okay. If this question coming 6 marks, remember this particular point. But the next one, when object lies beyond C. If you see what are this particular diagram, here object beyond C is there. Again we have to use 2 rules. But rule number 1 I am using here. If rays are coming parallel to the principal axis, after reflection passes through the focus. But rule number 3 I am using here. If ray coming on the center of curvature, after reflection it will follow the same path. Here beta we have to see their intersection. Sir, intersection is coming between C and F. And size, sir, it getting decreased, which means size of image is beta less than size of object, which means smaller in object. Okay. But a smaller bole to diminished. So what we can say, sir, whenever object lies beyond C, image is going to form between C and F. Sir, it will be real image, it will be inverted, and beta size will be diminished. Okay. But a third case, but this is important one. Why this is important? Because this is the case where beta object and image distance is minimum. Okay. How, sir? Object at C. Again beta 2 rules. Rule number 1 I am using कि whenever ray coming parallel to the principal axis going to pass through the focus. Beta rule number 2 I am using, when it come through the beta focus, it become parallel to the principal axis. So their intersection will happen just below the beta C. Okay. So we'll get same size. Okay. Real image, inverted image, locations are at C. Okay. You can see beta the image formed at C, real inverted and in same size. Again beta case number 4. Now beta infinity is done, beyond C is done, at C is done. Now we are moving between C and F. Then we'll move on F, then we'll move beta between focus and pole. अब देखो beta when object lies between F and C. Sir, object is here. Again I am using 2 rules. Beta rule number 1. If ray coming parallel to the principal axis, it going to pass through the focus. Okay. Beta rule number 3. If ray coming on the center of curvature, it will look, it will look beta. Look will convex. Here reality it will beta follow the back path, or we can say it will retrace its path beta. So we are getting beta intersection behind C. If you see the arrow size has been increased, which means beta image will be enlarged and location will be beyond C, real image, inverted image, or beta beyond C and enlarged image that you have to write in this case. But case number 5, whenever object is at F, but object at focus, you can see what this arrow at focus. Rule number 1 I am using, parallel to the principal axis, passing through the focus. Rule number 3, so center of curvature, it will retrace its path. If you see beta, these two become parallel to each other. These two become parallel to each other. If you remember, I told just one point just before. Whenever rays are parallel to principal axis, if incident rays are parallel, object at infinity. If reflected rays are parallel, beta image at infinity. So beta here image going to form at infinity. So what we can comment? Image form at infinity, sir, highly enlarged, real and inverted. Okay. But the last case in concave mirror, whenever beta object lie between pole and focus, ये बड़ा कमाल का पॉइंट है बेटा. दिस इज द पॉइंट ड्यू टू विच वी यूज कॉनकेव मिरर as a dentist mirror. Okay, so here beta object lie between focus and pole. I am using rule number 1. Whenever ray parallel will pass through the focus. Beta rule number 3, center of curvature, retrace its path. If you see, sir, they are not intersecting here and they are not parallel also. Okay, when beta rays are not parallel, you can extend their part. Which part beta? Reflected part. Okay, so if you beta extend back, you will see image will form behind the mirror. But this arrow size has been increased, but sir, object also of the principal axis, image also of the principal axis, which means beta image is virtual behind the mirror and image is erect in nature. Okay, so what we can comment, sir, image will form behind the mirror and it's virtual, erect and enlarged, big in size. Okay, now beta we are moving towards convex mirror. But in convex we have only two cases, one at infinity and beta one you place anywhere, not at infinity, between infinity to pole you place anywhere, will get image beta same between beta pole and focus. Beta first one, whenever beta object at infinity na, object at infinity, which means sir incident rays are parallel. In convex case beta, whenever incident rays are parallel, it looks like they are passing through the focus. Okay, so rays are parallel. If you keep your finger beta on the incident ray, it will look कि beta it is passing through the focus. Okay, so what we can say, sir, in case of convex, when object at infinity, image going to form behind the mirror. Okay, or beta behind the mirror case हो गया. And what we can say, sir, image will be point size, virtual, erect and highly diminished. But next case you keep anywhere. Okay, so again what I am using first rule, whenever ray passes through the whenever ray become parallel to the principal axis, it will pass through the focus, or but it will appear it is passing through the focus. But rule number 3, if it is coming on the center of curvature, it looks like it appear it is better follow back its path. So if we'll see beta intersection at this particular point. Okay, now if you keep anywhere, you will get same size beta, not same size, you will get same position between focus and pole, and beta size going to be diminished. Okay, diminished means sir small in nature compared to object. And beta one more thing, whenever you see na virtual image, virtual, always better draw virtual line or virtual image with dotted line. See in this case also beta, here in this case if you see here I have dotted here I have denoted beta this virtual image with dotted line. Beta here also in this case if you see this arrow beta, it should be beta dotted line. Okay, it should be dotted line, not solid line. Solid for real image, dotted for virtual image. But this is very small point that will make huge impact. Okay बेटा आगे बढ़ते हैं. अब देखो बेटा, these are normal concept what you have discussed till now. Now beta we have one more type of question in ray diagram in which ray will come at an angle. So how to solve this type of question? We have beta two steps for this one. Step first beta, draw focal plane, draw focal plane. Then step number 2, draw ray beta from C. Okay, then you have to see their intersection part. If beta converging mirror, then converge all of the ray at that particular point. If diverging mirror, then diverge beta all of the ray from that particular point, that is intersection point. Okay, if you see beta here they are coming at an angle. What is first thing, sir? First we have to draw focal plane. Beta this is concave mirror. Concave बोले तो sir this is going to converge all the ray of light. How to draw? Sir, first draw focal plane. Beta let's say this is F, this is C. One more thing, this F and C beta distance should be same from here, this one, and चलो बेटा एग्जैक्ट ही बना लेते हैं, कोई दिक्कत नहीं है, ये हो जाएगा C. Okay, so your first step should be beta you should draw focal plane. Focal plane beta always dotted line, so this particular is focal plane. The beta this plane is focal plane. But step number 2, draw the ray of light from the center of curvature. But this is center of curvature. I'm drawing line from here. Just a second. then we have to see their intersection point. If you see beta, this particular point is their intersection point. Now beta, this is concave mirror. Concave mirror means converging mirror. Converge all the ray of light on that particular point. Beta, converge all the ray of light on this particular point. Okay, so this should be the beta ray diagram. Don't forget these arrows. Arrows are very important. Okay, so how to do? Sir, first focal plane, then center of curvature, so ray of light, then beta if converging, then converge on that particular point. Diverging means from that particular point light should go away. Okay, so second case is beta diverging only. So beta, this is convex mirror, this is convex mirror. Beta, convex mirror means, sir, it is a diverging mirror. If it is a diverging mirror, it will better diverge the ray of light. So what is, how to do? Sir, first step we should draw focal plane. Let's have to see here same distance. First step it should be draw the focal plane. लो भाई sir, draw कर लिया focal plane. Now what we have to do? Then sir, a ray of light from the center of curvature. But a convex case na, in convex it will appear. It will appear कि it is passing through the center of curvature. Okay, so if I draw this line, just a second, yeah, dotted line. Okay, appear. So here beta I can say sir, coming also, outgoing also. Now if you see, this is intersection point. So from this particular point beta, all the ray of light should diverge. But this ray of light now, what I can draw this from here, if I draw, it will go like this, which means it looks like it is coming from this particular point. Okay, but this one I can draw like this, it looks like it is coming from here. But this one I can draw like this, it is looking, or beta, it looks like it is coming from here. Okay, draw perfectly with your scale. I'm doing very fast, so mistake may happen. So how to draw, sir, these type of question? First focal plane, second center of curvature, concave converge, and beta convex diverge. That you have to do. चलो बेटा अब देखते हैं important questions. That theory part is over. Now we left one lab activity that we'll do in next video. Okay, to write the difference between concave and convex mirror. अब देखो बेटा how to approach this type of question. For whenever they're asking difference type of question, we have to make the table. Beta, column 1 concave, column 2 convex. If you see beta, here I have written 4 points. First point, reflecting surface curved inward. Beta, क्या कर रहे थे? What we are doing in concave case? So this was the part of hollow sphere. Okay, here we are doing polish. Here we are doing beta polish, and this part will be reflecting. You can write this point also. I have written here. So reflecting surface curves inward. But this reflecting surface curved inwards. In case of convex, this is the reflecting surface curved outward. But a concave mirror also known as converging mirror. Okay, and convex mirror also known as diverging mirror. But if you remember, concave mirror was forming real image also, virtual image also. Virtual image in which case? When object lying between beta focal and focus and beta pole. Okay, but in case of convex, every time we are getting beta virtual image. So we can say कि concave mirror produce real image also, virtual image also. But convex mirror beta produce always real, always beta virtual image, not real, always virtual image. Okay, if you see beta point number 4, what we are observed in case of concave, sir, image was diminished also, enlarged also. In case of beta convex, image always going to be diminished. You can see beta this point here. Here beta we are getting diminished image in case of concave, and here we are getting enlarged image. But in case of beta convex, every time we are getting diminished image. Okay, बेटा ये तो हो गया डिफरेंस वाला क्वेश्चन. अब आगे बढ़ते हैं. Now beta their day to day life example. So how to approach this question? Beta first write their concept. What is concept? कि sir concave mirrors form, which mirror beta concave mirror form? Diminished also, enlarged also. So we have used on this particular point. Beta convex mirrors are always diminished. Okay, so this is the concept. Based on this we are using them. Beta how we are using? Rear view mirror. If you see in your vehicle beta, the rear view is there na, you will see everything whatever behind that your car will look in this small part. Okay, so which means object side getting diminished and field of view is more. So that is property of convex mirror that we are using here. Beta security or ATM also. In street light बोले तो बेटा if you see light getting spread, light getting diverged, that's why I use in street light. Then बेटा blind curve. Blind curve बोल दो चाहे बेटा, if you have seen in nowadays in metro station also we have, if you see on the first part they have the like this type of mirror, you can see behind one, like what is the behind the particular space on that particular mirror beta. But a concave mirror, sir, we are using saving mirror, flashlight, vehicle headlight, dentist mirror. But here I have given the diagram for concave. If you see, this dentist is using to see the teeth, but this mirror is concave mirror. So you tell me, which case is this? When object lying between focus and pole, image is virtual, erect, and beta enlarge. But here also same case, but a car headlight. So what is happening? But a light coming. Okay. Now after reflection, they are passing through the focus. When they are passing through the focus, beta, they become parallel to the principal axis. That thing we are using here. Okay. But we have one more use in the book. It is there. That is a solar cooker. Okay. So solar cooker, beta, will take acrylic surface and will take one disc. So we are applying that acrylic material sheet on this particular disc. So it behave like beta concave mirror. So light is coming beta from sun, that is infinity. So they will coming at infinity. So what will happen after reflection? They will pass through the focus. So at focus beta intensity of light will be high or heat will generate there. That we can say. But here you can see the diagrams or the beta application diagram of convex mirror. आगे बढ़ते हैं बेटा. If we use concave mirrors, rear view mirror in vehicles, what would happen? They would how to attempt this question, how to write. First write ki why we are using convex mirror. Sir, we are using convex mirror because it will give small object, size will be small, sir, and field of view will be more. Okay. If we use concave, what will happen? In concave beta we are getting image inverted, which means suppose beta this is a car and here we have rear view. If you are driving in this car, what you will see? Inverted image, which means if you are drawing like this, the behind you, but a car will be like this, inverted. Okay. The point of time they will pass through the focus beta, or बोले तो between pole and focus, they just turn beta upside up, downside down, and image will be enlarged. So that will make beta difficulty to drive. I have written all the points here. You can read it. Now beta, what would happen if spherical mirror were not invented? So what are the application we are using? Okay, this question is very simple. Whatever the application we are using, you can write just opposite. This will won't happen, this will won't happen. Okay, like this I have written here, you can read it, you will get answer easily. अब बेटा नेक्स्ट है कि what happened to the focal length of the mirror if it is broken into two pieces. देखो बेटा, the focal length depend on the radius of curvature. बेटा focal length formula क्या है? F equals to R/2. बेटा for making mirror we are using hollow sphere ना, correct? So this is center. But from here also radius r, from here also radius r, from here also radius r. Now if I cut it बोले तो बेटा I am cutting this part. Okay, but I am cutting this part. If I beta cut also, still radius of curvature is same, which means if you cut the mirror, focal length does not going to change. But what will change? Intensity of image will change. But suppose karo, initially here we are getting, suppose whole mirror was there, then we are getting all the, suppose ray light coming beta parallel, so all the image we are getting at infinity. Now if this part is cut, ray will pass through it, we won't get the initial beta intensity of light. So intensity will decrease, that we can say. Clarity of image will decrease, that we can say. Okay, but focal length does not going to change. You can read it better from here. But next, what would if we use convex mirror in car headlight? अब देखो, why we are using beta concave in car headlight? Because it is giving sir converging image. Or beta converging is going to straight. All the beta lights are going to straight parallel beam. But if we use convex na beta, it get diverge, it get spread. So field of view, like what we are seeing in the night, okay, we won't able to see exactly if we use convex mirror. So I have written all the points in this question, you can read it. But next is does the focal length of the mirror depend on the surrounding medium? Justify your answer. देखो बेटा, focal length is depend only on radius of curvature. If I say beta this is concave mirror, okay, so concave mirror is there right now, this in the air. If I keep this in the any water, kerosene, oil, whatever, radius of curvature does not going to change, which means beta focal length also does not going to change. But in case of lens it will different beta. Okay, we'll cover that part also. Now beta there are some bit questions, some very important bit questions which has been came in your PYQ also. Okay, but first the relation between radius of curvature and focal length, what we know, sir, f equals to r by 2 or r equals to beta 2f. Now see which option is correct. Beta C. Which mirror always forms virtual image? अब देखो बेटा, concave mirror was forming virtual image also, but not always. Only in one case, when object lying between beta focus and pole. Okay, so what we can say, always na beta. So convex mirror going to form always a virtual image. So convex will be the right answer. Beta sign convention. What are the sign convention? Image, distance and object. Beta first we have to tell about image, then we have to tell about object. Object is placed in front of a convex mirror. Beta convex mirror. Object is here. Image will form this side. Object, image. What I told, in front of the reflecting surface, negative. Beta this is the reflecting surface. This is sir polishing. So this is going to be reflecting surface. Object in front of the reflecting surface, which means negative. Sir, image side of the polished surface, positive. So beta negative positive combination we should get. So we are getting option number D. Okay, but question number 4, magnification of the image is m equals to -1, then nature of the image is, beta m equals to -1. याद करो बेटा, negative sign is telling image is, beta image is inverted. Okay, beta 1 is telling sir same size. Now we'll see what are the options in the given: virtual inverted, real erect, virtual erect. So they are not asking in term of size, they are asking what in term of image, virtual or real. So what we can say beta, inverted image. So inverted image beta always a real image. Okay, so there will be, which option will be correct? Option number C. So real and inverted. Beta question number 9, the characteristic of an image formed by concave mirror when used by a dentist. देखो बेटा, concave mirror used by dentist. So which case they are talking? They are talking beta when object lying between focus and pole. In that case only we'll get virtual image, erect image and enlarged image. Okay, so virtual, erect and beta enlarge. So option A will be correct. In the case of concave mirror, when will the distance between real object and real image minimum? देखो बेटा, ये केस है concave mirror का. In concave mirror, when object lies at center of curvature, image will get at center of curvature only. So distance between them how much? 0. Beta sir, object also see, image also see. So distance between them 0. Okay, and their real intersection was happening, which means image was real. So we can say beta when object is placed at C. So that's all in this video. We'll discuss more in the next video. Till then, take care. Bye bye.